Hello there. Good evening, everyone. Right, we want to continue with our discussion on analytical question today with regards to mechanical drawing. Yesterday, we touched on one question from 2018. So today we are looking at another one from 2019. Remember, we want to look at the analysis and the approaches that you would require in order to answer the question on mechanical analytical. So let's enjoy today's lesson. But before we do that, let's look at what we are going to focus on. Like I said, it's analytical, it's a revision task. So we are going to look at question 1 of paper 2. We are looking at ways of responding to this particular question and how to get these answers and how to present those answers in terms of our exam. So after this lesson, we should be ready to face any paper 1, question 1 in terms of analytical. Like always, right, we focus on the issue of this great statement: I hear and I forget, I see. Sorry about the noise in the background. Right, like I said, we focus on this great statement: I hear and I forget, I see and I remember, I do and I understand. So that's what we aspire, or we want you to achieve at the end of the day in terms of the lesson. So let's go straight to it and look at this question paper in terms of right, like I said, this is last year's paper. That's November 2019. Right, question 1, analytical, right, and it's mechanical. Right, given information, 2 views and a section of a mechanical jig. So we now know that what we are looking at is called a mechanical jig. A title block, right? We shall look at the title block and a table of questions. The drawing has not been prepared to the indicated scale. Yesterday, we spoke about this and we said that if it's not indicated to or drawn to the indicated scale, you'd find that we use this abbreviation NTS, not to scale. Right, so complete the table below by neatly answering the questions which refer to the accompanying drawing, the title block, and the mechanical content that is given. Right, okay. Earlier on, we spoke about the title block at the bottom. Right, so this, right, is our title block. Right, it's a mechanical title block. Remember, we also have got civil title block, but this one has to do with mechanical. Right, so whatever information that we require, right, about 98% to 99% of the answers we should be able to get them from this paper, and either from the diagram itself or from the title block. Right. What was Ingrid's responsibility in terms of question number 1? So we go to the question number 1, we look at this. Right, what was Ingrid's responsibility, right, in terms of this work? Right, we go to the title block. What is critical? Let's look for, right, we are going to look for this, right, this name, which is Ingrid, right, and we also come down here, we look for that, right. So next to it, you would find the responsibility. The responsibility in terms of Ingrid's work, it was checking, right? So you could write checking, or you can also write to check, right? So his responsibility was basically to check or checking, right? What is the manufacturer's website address, right? So the issue is you now look for the website address, right? In terms of the manufacturer, right? You look at that, you go to the manufacturer. The manufacturer is the person who was assigned to produce this jig, right? Look for something like www something, that's the website, we know that. Then this is what we are looking for, right? It's www.foundry.co.za, right? It's written in small letters, so you should also write the same thing, right? W dot foundry .co.za, right? Okay, I'm sorry about this, right? So it's www.foundry.co.za, okay, right? That's when the focus is not fully exposed in terms of your visualizer. Sometimes you end up forgetting that it's out of focus. But in terms of the response that we wanted, it's www.foundry.co.za, like that. Right, so the next question would be, what is the file name? Right, so you are going to look at the term file as well as name, okay? Right, if you look at this, let me just move this one slightly. Right, you look at this, you would find that this is the information that we require, file name, okay? Then you go back to the answer, right? Right, so the file name is MJIG MJIG dash 12 dash V5, like that. Right, so it's MJIG dash 12 dash V5. Right, so you look at the key words that are being related to with regards to the question, and also look at the information, especially in the title block. If it is not technical, you find that that information might be in the title block. Right, who is the client? Right, if you check here, right, commissioned by JR manufacturers, right? JR manufacturers, 105 First Avenue, right? That's bricks. Right, okay. So if you are commissioned, you have been asked to do something on behalf of someone. So you look at this information, right? This one is Form Engineering. That is the company that had to, or that was commissioned, or that was asked to do the job. So the persons or the company which commissioned a Form Engineering is JR Manufacturers. So we come here again. right? And write J right, like that. JR manufactures. Right, how many jigs must be manufactured? Right, here you'd find that you can look at the quantities, you can look at the number required. Right, those are some of the terms that may be related to the quantities. Right, if you check on this one, you'd find that quantity, right, it's given, it's 30 units. So you would write here 30 units, okay? Right, even 30, it would suffice. What is view one called? Right, let us look at view one. Remember, when we are dealing with paper two, right, we are always dealing with third angle orthographic projection. Whatever we see here, right, it's related to third angle orthographic projection. So technically, this is our top view, and this is our front view, but the front view has been cut, is seen as a section. So we can therefore say this is a full section, since we are able to see from left to right, okay? Right, so we can write here full sectional front view. Right, if you don't have space, the view may be left out, okay? So we have got a full sectional front view in terms of the view one. Right, what type of section is view RR? Right, we are talking about this one. Right, we are talking about this one. Right, now you'd find that this is the cutting plane, right? That's the cutting plane. All right, under normal circumstances, the direction should have been facing the other way around, but because this is illustrating a specific section, right, along this cutting plane, we know that in third angle orthographic projection, what we see when you are looking from this side, you should be able to include this detail as well. But because it's specifically looking at that particular part, right, this kind of section is what we refer to as removed section. That is this section, right? It's shown here in terms of the position of the cutting plane, but it has been removed. So it has been removed and drawn there. So it is referred to as right, it is referred to as removed section. Right, name the type of section produced by cutting plane TT. Right, so you have got cutting plane TT, which is starting from the left. Let me just show you from here. Right, we have got here, it's starting here, that's then all the way like that. Right, so there is a specific cutting plane, right, which is required to show specific detail, not in a single plane, but you'd find that it is multi, right, plane in terms of the position. Right, you would cut like that, you take it up, you cut horizontally, vertically, like that, horizontally, then vertically like that, okay? Right, so that kind of cutting plane, it can be referred to as a multi-plane. Basically, the plane which is being talked about, we have got the vertical plane, we have got the horizontal plane. So when it is cutting like that, it's horizontal, then it's vertical, horizontal, vertical, horizontal, vertical, and horizontal like that. So we can also refer to this one as staggered in terms of the cutting plane. It's a staggered cutting plane. It can also be referred to as an offset cutting plane, but where you would want to show a section by going through or defining certain details, okay? Remember, if we were to cut like that, we're not going to show this detail, that detail, and so forth. But because you need to show that particular detail, right, you would stagger it or you would offset it in terms of its original direction and cut that, then still offset it and cut that like that. So we refer to that one as offset, multiplane, or staggered, okay? So you would come here, right, and write offset, multiplane, but I don't have space, but you can also refer to it as a staggered cutting plane, right? Which means it is supposed to accommodate, right, the different aspects of an object which are not necessarily lying in the same plane, okay? Right, they are not necessarily lying in the horizontal plane, so you need to negotiate according to that particular detail. Right, determine the complete dimensions at A, right? So once you get that, you'd go, this is our point A, okay? Right, so what is the dimension from here to there, right? Which is that, which is that, which is this, right? So you look at all the points which are similar to that which is indicated by point A. Do not be quick to say it's not there. Sometimes you'd find that it will be shown in the front view, whereas it has been asked in the top view. So check everywhere and look for that information. If it is not there, now you go to the title block, right? Right under the title panel, you'd find or unspecified radii, okay? Right? Or unspecified radii. Radii is the plural for radius, okay? It's 4 millimeters, right? So, or radius or radii, which is not given, you should use a size of 4 millimeters, okay? So you would come here and write, because it's not given. And it's important also to note, right? When we are looking at this, we are looking at a fillet, okay? Right, I'm just saying this in passing, right? In case we would come across something like that, this arrow is pointing to a fillet. When it is on the outside, like we know, it is also referred to as a round, okay? So this one, right? That's also a fillet, right? We are just talking about this in passing, right? So that the radius of the fillet is not given. So we are going to use the unspecified radius, right? Which is 4 millimeters. So we are going to write here, right? 4 like that. Then B, let's look for B, right? Here is our B, okay? Right, at the top there is our B. Right? Now, we are given this one from here to there. We are not shown that size, but what we are given, you see this is equal to that point, okay? Right, if you were to draw a line, right? Right, if we were to draw a line from here, that is the line that we want. And if we were to draw another line from here, you'd find that that's what we have. Right, we know that in terms of drawing, all right? Normally, this is associated with what we refer to as chambers, all right? For rounding off, for finishing. Right, if we've got a shaft, let me just sketch something. We've got a shaft, we have got this, right? We have that. Maybe let's break this one, but just to show this is a shaft, right? But this shaft might be threaded like that, right? Then you would find that in terms of the thread, we have this, we have that, then we have got the thread runouts, we have got the thread runouts like that. Then here, right, we chamber like that, right? What it means is that the distance from here to there is equally the distance from here to there. So we can as well outline this like this. Take this one, take that, and that. Right, so then we take this, right, and also that, right. This one is normally outline the end of the thread, then we show the thread runouts. The significance of what we are talking about is, right, if we are given the distance from here, right, to there is not specified, but the distance from here to there is specified as, say, 2 millimeters like that, right? So what it means, if we make use of a 45-degree set square, okay, right, this distance also is equal to 2 millimeters, simply because we have mitered that. So if we look at this setup from here to there, they've used an angle of 45 degrees. So what it means from here to there is 15. Automatically, the distance from here to there is also equal to 15. So we would come and say B is equal to 15 like that. Right, B is equal to 15. Right, then we also have got C. Right, C is here, right? That's our C. Right, so from here to there, we need this distance. Right, we are not given that distance here. We are not given that distance here. But if you go to the top part, right, remember this part is referred to as a lag, okay? Right, in mechanical terms, that is known as a lag. Right, so from here to there, right, if we go at the top, you'd find that there's a radius that is given, radius 6. So from here to there is 6, from here to there is 6. This is the same as that, which is the same as that. All right, so the 3 lags would give us the information that we want in terms of the upper part. So the distance from here to there, therefore, is equal to 12, which is 6 times 2, okay? Right, so we can write 12 there. Right, then D, right, we look for D, right, always check, right, where do we find that D? Right, D from the bottom to the top. Sometimes you'd find that even that removed section might come handy in terms of giving you the information that you require. Right, so we have got D, we have 44 from here to there. Then we have got the distance from the center. Remember, this is cut from here to this. This is the common center line, which is the center line like that. So from the center line going downwards, we've got 25 and 15. So we are going to say 25 plus 15 plus 44. Right, we have got from here, that's 44, right, plus 25 plus 15. Right, so the answer that would require there, therefore, would be 25 plus 15 plus 44, which would be 84. So we'd write 84 like that. Then E, where is our E? Right, we get our E there, right? Always check and find out where the E is, right? If you check, this is a section through a threaded hole, okay? Right? Right, or it could also be referred to as a taped hole, okay? Right, so it is threaded, or it can also refer to as, right, it's one and the same thing. All right, okay. Right, if we check, let's go to the information. We find that information at the top there. All right, we have got that information. It's M10 by 1,5 thread. Now, what is critical in terms of this? If you have got this information like that, you would find that there is a circle which is incomplete and not as dark as the other one. Then you now find that there is another one like that, which is complete. Right. The moment you see something like that, you would know that this is an internal thread. Okay. Right. Some would call it a female, right? A female thread. Right. What it means is that, right, if we were to draw this one as an elevation, right, we would bring this one down, we would bring this one down, right? Then we outline this part, right? You are able to see this line, right? And you are also able to see this line. It's outlined, right? If we had an extension in terms of, right, this is the depth of the thread, right? So from here to there, that's 1,5. From here to there, that's 1,5, okay? Right, but the distance from here to there, that's 10 millimeters, which is give you M10. So if you want to find the distance from here to there, right, which we also refer to as the internal diameter, okay, or the minimum diameter, right, this one would give us the maximum diameter, okay, right, it will be minus 1.5 times 2, which would be M10 or 10 minus 3, right, which would be 7 millimeters, okay? So the size that we require in terms of the distance from here to there, right, you need to subtract the depth of the thread, right, like I've shown, from here to there, that's 1,5, 1.5, and from here to there, that's 1.5, 1.5 plus 1.5, that's 3, being subtracted from the nominal diameter, which is 10, you are going to have 10 minus 3, which would give you 7, which is the inside diameter. So 7 is our inside diameter, like that. So you would write here, diameter 7. Right, so as much as we said that some of the answers you would find from the paper, right, in terms of the information that is provided here, yes, it's provided, right, in terms of 1.5, but if that information is not provided, just to make sure that if you face a similar situation, you'd find that you may be given M10 like that, but you are not given the depth of the thread. Depth of thread, right, is equal to 0.1 times the metric size, which is M10, which is the same as 0.1 times what? Times 10, right? And what do we get? 0.1 multiplied by 10, right? You would find that if you are not given, we're going to get 1 millimeter, okay? So 1 millimeter times 2, you are going to get 2 millimeters, right? Subtracted now from 10 millimeters, the answer was going to be 8 millimeters, okay? But in this case, you are given 1.5 is the depth of the thread, so you make use of that. Right, determine the total length of the jig. right? Determine the total length of the jig, right? If we are talking about the total length of the jig, we are given this information from here to there, that's 154, right? But the 154 will take us to this point, right? And we know that from here to there should be a specific measurement that we need, right? You look at the size of the lads in terms of the top view, right? We have got the distance. If we check at the top, we have got the distance from here to there, that's 30. So you can bring that distance here, right? So from here to there, that's equal also 30 millimeters. So from here to that's 30 plus 154, and the distance from the center line, which is the center line to the end, which is from here to there, right? If we measure, show that we have got 15. Again, we take the size from the top, which is from here to there, that's 15. So it's 15, 154, and 30, which is also 30 like that. So let's add and see. Right, we have got 15 plus 154 plus 30, right, would end up getting 199. So you would come here, the total length that we require is 199. Right, some of these questions are purely mathematical in nature. So that's why you find that as an engineer, you need to be good also in mathematics. Otherwise, you'll find your career challenging. Right, okay. Name the feature at F. Right, so the key there is to look for point F. Right, here it is. That is our point F. Right, if we look at this, we have got that. Right, if it is not hedged like that, right, but as you can see, this side is hedged, okay? Now, there is a rule, right? If you cut this particular part of the machine, okay, or a component of a machine, you would find that you are not going to show it in section if you cut it along, okay? But if you cut it across, you would show that one in section. So what part is it? Right, we refer to this part as a web, okay? Right, sometimes it can also be referred to as a rib, okay? So we would say web or rib, right? And this, mostly in terms of engineering components, right, it is there to strengthen, right, to bring firmness to a mechanical component, right, for stability, right? So you end up anchoring or supporting with what is known as a web, okay? Right, a web for support if you have got two pieces like that, which basically would require to be joined, okay? Right, would know that if not supported, this part would suffer from stress and strain, okay? Right, from stress and strain, and it's likely to pull this one or pull that one, then there's a break. Right, so in order to bring support, right, you create a member like that. This member will refer to it as a web, okay? Right, if we were to draw this one pictorially, you'd find that you may have something like this. We have that. So then you mark this, you mark that, take this, bring this one, bring this one. Now you have got the you now have got this part. right? We refer to this part as a web, okay? Right, such that if we cut along, right, we don't show this one as in hatching, right, we would only hatch this part like that, right? Then this one is left out simply because we don't want to distort our view. So this one is a web. You'll find that for some circular components, we may have something what we refer to as a rib, okay? Right, but the function and the purpose is basically the same. And in some cases, you'll find that these terms can be used interchangeably, right? One referring to the other or meaning the other. So would you say this one, right? That part is a web, it's a rib. But because here we are able to see the thickness of that web, okay? When we cut it, we show it in section. This is referred to as having been cut across, right? You have cut this one across, okay? Right, in terms of the web, but this one is said to be cut along, okay? Right, and this one cut across. So if you cut across and you are able to see the thickness of that particular web, you hatch it. But if you are not able to see the thickness of that particular web, you don't hatch it. So these are some of the small rules that you can apply, right, in terms of defining which part in terms of the web can be hatched or cannot be hatched. Right, what is the minimum depth of the thread required for the wall at G? Right, let's look for G. Remember, we look for keywords, okay? This is where we find point G. Right, now, in terms of the minimum distance, right, you would find that if you are not given here, right, you can also be given it as part of the annotation, right? We have got M10 times 1,5 thread. Remember, I've already explained the concept of 1,5. We said that is the depth of the thread, okay? Right, the M10, that's the metric size, right, in terms of the threaded part. Right, then minimum 18 deep. So this is the information that we require for that particular question. So you would come here and write 18, right? You can simply write 18 or 18 millimeters, okay? Remember, in drawing and in engineering, the moment you write 18, the assumption is that you are talking in millimeters, okay? If you are referring to 18 meters, you need then to specify 18 meters. If you are referring to 18 centimeters, you specify that you are referring to 18 centimeters. But if it is simply 18, it means 18 millimeters. Why? Because the millimeter is the standard unit of measurement in engineering. Right, name the feature at H, right? So the key there is to look for H. We come here, this is our H, right? What is the feature at H? What is the feature at H? Sometimes if you are not given additional information, remember it is asked here, but you'd find that the answer is at the top. We also saw it here, right? But the answer was here at the top. So you need to coordinate the two views. Look at the two views and see which one would give you the answer, right? In most cases, the answers would be there, and you need to be careful in terms of which view you are going to check. Do not just look at one particular view where the question has been directed to, right? They want to see whether you are observant, whether you are able to check as quickly as possible and come up with the answer. Like I said yesterday, you'll find that you are not expected to spend more than 20 minutes on this question, okay? All right? You need to make sure that you get the answers as quickly as possible. The one that you cannot find, you leave it for a moment, then you go on to other questions. But because the mind would always be looking for that answer, subconsciously, it will still be searching. So when you come back, you would find that you will be able to get that particular answer. Right, okay. Name the feature at H, right? We have got this. This is our H. If we look at this corresponding detail in the top view, you find that the answer that we want, we need this information, which is known as the countable. Right? Right, the countable, right? When we are talking about a countable, right, you'll find that you may have information like this. I'll provide this one as a center line. You have got that. You have got this. This is a piece of work that you are looking at. That's the center line. Now, you want certain components to protrude outside there, right? Say it's a washer, it's a nut, and so forth. You want to hide everything, right? So you drill, right, a much bigger hole like that. Then you insert whatever component such that it would sink into the hole like that, right? Now, this part, right, which we have created here, right, is known as the countable, okay? Right, you'd find that in some cases, it may take this shape, right, like that, like that. Now, when it is like this, in terms of the part that has been cut, it is referred to as the countersunk. Right. And in most cases, it will be there to accommodate the screws such that they would not show outside the piece of work that you are working on. Right. And that wall is not hedged because there is nothing solid that has been cut. So these are some of the things that you need to make sure you understand in terms of analytical drawing. So we have got that information that's a countable. So you write here, right? Sometimes you don't need to write everything, just like that, countable, right? Diameter 16, right? But just countable, it's fine, right? Or you can write in full. Countable, like that. Right. How many surfaces of the jig must be machined? Right. If we are looking at surfaces which must be machined, remember it is critical to understand, right, not only drawing in terms of presentation, but also need to understand annotation with regards to machine drawing. Right, okay. So when you see something like this is what we refer to as a machine symbol, okay? So if you are asked this particular question, how many surfaces of the jig must be machined, you count these, right? But sometimes be careful, right? One part of the component might be similar to 2 or 3, but they would have shown the machining symbol on just one. Like here, we can count, we've got 1, 2, 3, 4, 5, 6. Do we have another one? Right, we've got 1. We have got 2, 3, 4, 5, 6. Now, we have got 6. But let's look if we have got any part which is similar to the ones that have been identified as machined. Right. This one is just 1 on its own. The same applies with that. It's just 1. The same applies with this one. Right. But if you look at the last one here, right, which we refer to as a lag, okay? If you look at the last one there, right, you'd find that we have got 1 in terms of the top view. Let me just bring this one. right? We've got 1, we've got 2, we have got 3, but the machine symbol has just been shown on 1. So if we count, we have got 1, 2, 3, 4, 5, 6. So the other one, not this one, would be 7 and the 8th one, okay? So you would come here and write 8. Right, describe the hatching mistake on view 1. All right, okay? Right, so if it is a hatching mistake, right, you are going to look at the mistake in terms of 1, right? It could be direction of hatching lines. It could be the spacing in terms of hatching lines. It could be certain parts which would otherwise not be hatched, which are hatched, and so forth. So you look at that, like if you have got hollow parts, right, which have been cut, of course, right, if they are hatched, like here, if you look at this one, the cutting plane is passing through this line, but from here to there, there's nothing that is cut, right? And as a result, if you find that that part has been hatched, it's a mistake, okay? Right, if I look at this, the hatching lines, in terms of direction, it's okay. But if you check here now, right, you'd find that there has been a change in terms of direction. Whereas this is one component that has been cut by one cutting plane, though the cutting plane is staggered, but it's one continuous cutting plane. And as a result, the hatching lines should face the same direction, okay? Right, so we can say hatching lines facing different directions. Okay, I'm going to steal some space here. Right, hatching lines facing different directions. Right, going to the left and going to the right like that. It's not allowed and it's wrong, okay? Right, with reference to tolerance, yesterday we spoke a bit on tolerance, right? Determine the minimum height at J, right? The first thing that you would need to look at is letter J, okay? Always identify the part of reference, okay? All right. Once you have identified that, now you work on ways of responding to the asked question, okay? Right, so we are looking at this. That is the height, that is the upper part, okay? Right, if we push this one like this, right? We push it like this, you'd find that there is a certain measurement that has been given. It says 31 plus 0.25 or 31 minus 0.15, right? And they are talking about minimum, okay? Right. If it is minimum, right, which means you are looking at the one that you are separating, right? Remember, it's 31 like that. Then it says plus 0.25, then minus 0.15. Right, so if it is minimum, it's about subtraction, right? If it is maximum, right, it's about addition, okay? Right, and here it's subtraction, right? So we are going to take 31 like that, minus 0.15, then we get the answer. But if it was the maximum size required, it was going to be 31 plus 0.25, and we would get the answer. This is maximum, right? And this is minimum, right? Now, if we go to our answer in terms of the mark allocated, right? It's just 1 mark. But if it is just 1 mark like this, you can simply say 31 minus 0.15 is equal to, right, 30.85, right? You write it like this, 30.85, right? That is our answer, right, with regards to the question that has been asked. But if suppose there were 2 marks here, you were supposed to indicate 31 minus 0.15 would give you 30.85, right? So that this would be 1 mark and that would be 1 mark as well. But if it's just 1 mark, that would suffice, that's enough. Now, we now go to number 17, right? Number 17. Right, with reference to the machining symbol, match the letter on the symbol with the correct label in the column to the right of the question, okay? Right, so remember I said at some point, right, you need to be familiar with the engineering terms, with all the drawing terms and annotation techniques that are required. So it's not only about coming up with the top view, the front view, the sectional right view, the sectional left view, and so forth. Right, you also need to be familiar with the notes associated with machine drawing. Right, we have got here, this is for question number 17. Right, we have got B, right, it's already given. Right, when you are looking at a machine symbol, okay, right, it would come like that. Right, this is just ordinary. Right, if there is no additional information, right, it's basically saying machine, okay? But the moment you see something like that, which means there is additional information which is required, and in most cases, if you look at A there, right, that's where you would state the degree of roughness in terms of finish, right? In terms of your finish, okay? All right, do you want it to be very smooth or rough in terms of your finish? That there should be a value which is given here. So that is a value of roughness, okay? Right, let's check if we have got that. So we are going to say that is right in terms of here, that is our A. Right, then E, right. Now, you'll find that there is a value which is associated here, right? And this value, it has to do with an allowance, okay? Right, an allowance or a tolerance value. Right, this tolerance is to say that whatever you do, right, make sure you are able to leave at least, say, 2 millimeters, 3 millimeters in terms of the machined parts. Technically speaking, when we are talking about machining, we are talking about the removal of excess material in order to come up with the desired shape, okay? Right, in terms of an engineering artifact or a component. So if you want to remove certain material from a piece of work that you are working on, right, we can do that by way of machining. Nowadays, you find that we have got programmed lathe machines that can bring about the desired result by simply working on the material on their own. Right, so, but you can also give a certain allowance, okay? Right, that would make it possible to correct and refine without necessarily affecting the material and condemning it totally. Right, so E, right, would come here. That is for an allowance. Then we have got D, right? The D, you'd find that in terms of machining, right? Right. In the older days, you'd find that we can talk about a chisel, you can talk about something that you can use to remove excess material, okay? Right, so this is about the direction. Are you going to do it horizontally? Are you going to do it vertically? Are you going to do it perpendicular to the surface that you are working on? Are you going to do it right round the material and so forth? So this describes what we refer to as the direction of lay, right? Which is D, so you come and write it there. Then you have got C, right? Right. C specifically is about if you are working, right, for mass production, right, you would want to come up with a sample, okay? Right, the sample or the part that you would want to test in terms of your machining and so forth, right? So C is about the sampling length, okay? Right, the sampling length, how far you are going to work on an material in order to define the effectiveness of that machining process that you are doing, right? You can specify that machining assembling length there. So that is for this value what? C, right? And B, as you can see, it's polished, but sometimes this is about the method that you are going to use or apply in terms of machining, right? It could be milling, it could be different other types of machining methods that are applicable. So just be familiar with this kind of information and also look at the kind of information with regards to a welding symbol, okay? Right, that also can come as part of paper 1 and question 1. So from here, right, if you were not familiar with the machining symbol, look at it closely and study it as well as look at a welding symbol so that if you are asked to state the elements of a welding symbol, you should be able to do that as well. Right, 18, which is our last question. In the space below, answer 18, draw in neat freehand the symbol for the projection system used. Right, remember we said from the beginning, right, when you look at this particular question, right, or this particular paper, right, it's in third angle orthographic projection. So in terms of projection symbol, you won't associate this one with first angle orthographic projection always, right? It is related to third angle orthographic projection, even if it's not given, but the system that has been used here, right, in terms of describing these views, right, it's about third angle orthographic projection. So you would come here, faintly first, describe like that, right? You draw 2 concentric circles, project, right? Then you connect like that. There you go, right? If you want, you can, right? This is critical, like I explained yesterday. The other center line is already given, okay? You'd find that in terms of how that symbol is marked, right? The first circle, the second one, the center line, this line, this line, this line, and that line. That's how those marks would be awarded. The last one would be for the free hand, right? The mark would, so all in all, you have got 1, 2, 3, 4, 5, 6, 7, 8. 8 divided by 2, you end up getting 4 marks, okay? So this is it. This was last year's paper, 2019, November 2019. Right, so no matter which paper you are looking at, please make sure you understand the principles of drawing and also the application of drawing techniques and that knowledge which is associated with the drawing, right? So that you'll be able to answer these questions with confidence and properly. I hope you enjoyed this lesson. Tomorrow we are going to finish with our analytical, then we'll start with assembly drawing, okay? right? So we have got one more paper to look at in terms of analytical. This is a very important question, okay? Right, remember it's 30 marks. The assembly drawing is 90 something marks. So the two would give you about 60% of the exam. Right, so let's not take lightly the importance of this particular question, okay? Right, learn to answer it and answer it with confidence. Where you don't get the answers, where you don't understand, now refer to the textbook so that next time you face a challenge like that, you should be able to do it properly. Thank you and good night.